Okay, so we are here with the infamous Jogger problem in homework assignment 2 of Long Kappa. So, and forgive me if I sound bad, that's probably because of Corona. But anyway, so in this problem, we are given, or let me read it out to you. A jogger runs 138 meters due west, then changes direction for the second leg of her run. At the end of the run, she is 356 meters away from the starting point at an angle of 20 degrees north of west. What were the direction and length of her second displacement? So what this is asking for us is we're trying to find the second vector. So we're given vectors 1 and 3, and usually in class we would be given vectors 1 and 2 to solve for 3, which vector 3 is basically going to be the addition of 1 and 2. In most cases. Same here, but we're only given the unknowns, mostly of vector 2. However, in the table, we are also given unknowns with the components of vector 3. We need to find those as well in order to help solve the problem, because what we're given is the magnitude for vectors 1 and 3, and the x components of 1 and the direction of 3. Which is 20 degrees north of west. Keep in mind, this chart is saying all with respect to north of west. So if you're asking, well, 138 meters is traveling to the west, shouldn't that kind of be considered negative? Not in this case. This is all with respect to this coordinate plane here. Nothing's really specified as negative, so that's not really the case given here. We're just supposed to say the direction, which is where it is, which is west in this case, and then how we can correlate with that. So if we say negative, we could say negative if we were on the east side, but because we're on the west, that's what we're trying to solve for this problem in this case. So what do we need to do exactly? Because we sketched it out. We have vector 1 traveling solely west on its x component, while we realize there's no y component whatsoever. And then we see vector 3 traveling upward north of west 20 degrees at a distance of 356 meters ahead. But what about vector 2? And that's what we're solving for. So here's what we need to do. So the problem wants us to find the magnitude and the direction. So in order to find the magnitude, first we need to draw and sketch the problem, which is what we just did here, and create a table with all the variables, including the unknown. So when we look at that, like I said, the unknown is all of vector 2, including its components, magnitude, and direction, especially since we need to find the magnitude and direction in order to solve the problem. But we also have the unknowns of vector 3 with their components too. So how will we solve that? Well, and since it's the first thing we need to do is find those components. Well, to do that, we need to go down here and use the equation. I'm not sure what it's called exactly, but the equation is supposed to be the magnitude of whatever vector you're using times the cosine of the direction, or that angle measurement they have. So, and what is the purpose of this? Well, this purpose is to find the x and y components, because what I just named you is the equation for finding the x component. The y component is the same thing, but only using the sine function. And why is that? Well, when you think of sine and cosine usually associates with x coordinates because, well, if you use SOHCAHTOA, it's supposed to be adjacent over hypotenuse for cosine. And the adjacent typically is going to be the x side if we're finding an angle relative to the origin. And the sine, when it says opposite over hypotenuse, it's usually that y length that we're trying to, illustrate here. So there you have it with the reasoning behind that. But going into this, you plug in 356, which is the magnitude we have given, and 20 degrees, which we were given in this case too. And because of that, we were able to find the x and y components of vector 3. Then what we need to do is use algebra to solve the components of V2. And how are we going to use algebra? Well, V3, you simply to find the components of V3, you have to add V1 and V2 in order to find that, since V3 is the addition of vectors V1 and V2. So the components must be added. So let's rearrange the formula, or the equation there, to get V2, which is equal to V3 minus V1, with both of these. And then plug in the numbers for all those components, and we should get, for the x component, 196.53 meters and 121.76 meters. Now keep in mind, it does look like I'm rounding here, but in the calculator, I have like all the numbers in, because typically what you want to do in these equations is you don't want to round until the very, very end. So going into this, now that we've found the components of V2, now we need the Pythagorean theorem in order to solve the magnitude of V2. And that can be illustrated by the square root of V2x squared plus V2y squared. And plugging those numbers in, we should get a result of 231 meters. And the reason why I rounded it here is because the significant digits based on the problem go up to 138 meters and 356 meters. So there you have it with that part. So now that we found the magnitude of V2, then now we need to find the direction. And we need to use arctangent of V2 and V2x and V2y. Oh, sorry, that's supposed to be V2y and V2x in order to find the direction. So going into this, and I just put dir there to kind of, for me to understand. So we have 90 degrees, and the reason why I'm doing 90 degrees minus arctangent of this is because this is due west. Arctangent typically means you're finding the degrees on the right side. So what I mean by that is look at the coordinate system. If we were to find V3, for instance, the angle here, you would simply do arctangent. But since we are doing this direction, we're going, I guess, clockwise instead of counterclockwise. Then that means we need the angle here, which is north due west, which essentially is 90 minus the arctangent of the components of that vector. So going into this, we plug in 90 minus arctangent of 196, and then divided by 121, and then we get 31 degrees. Give or take, it's 31.7 or 8. Technically, it should be 31 based on the significant digits of the degrees that we were given. But still, I think you can plug this answer in, and it was fine on log kappa. So now to check, to see if we have it right. For the most part, this problem is self-explanatory. There's not really a reason to check because, you know, you needed all those other variables in order to do so. But if you do want to check, then you have to find the resultant components of V3 or V1. And to do that, use those components to calculate the magnitude and direction. So I checked this by finding V3 and components, and I was able to get the same type of components that V3 had originally, and that I calculated beforehand at the early part of the problem. So then I used, tried to find V3's magnitude, which did equal roughly to 356. And then in the direction, same thing. I did 90 minus, because remember, it's still due west. And calculated roughly the same thing, 20 degrees.